Alright, hi guys. Quick little video here on trig functions, and we're just going to talk about the basics. So we know our sine, cosine, cosecant graphs. We know what all those look like. We want to talk about shift laws for trig functions. So there's three types of shifts. One of them is called amplitude. And you've heard of these before. Amplitude is when you're changing the range of the function. So I'm going to write a definition here. Changes the range. Remember, range is y value, so it's changing on the y-axis. Then we got something called the period. And this changes the frequency of the graph, or the width of the graph. So I'm going to write changes the frequency. And if it helps you kind of think about frequency, I think of it as like, here's a stretched out curve, and then here's one that's a little faster. That's a change in frequency. So something like that. And we'll talk more about it in a minute here. And then the other thing we have is a phase shift. And it's just a shift, like a shift law. So a phase shift is just a regular shift, and it just moves the curve left or right. So I'm going to write that. Moves the curve left or right. So we got three different things. We got amplitude, period, and phase shift, and it depends on what kind of function you're looking at. So we're going to kind of talk and compare a couple of rules that you need to know, I guess you could say. And these are just really general trig laws. So here's the next thing we're going to put up on the screen here. So let's say you have y equals the sine of x, or y equals cosine of x, or tangent, or whatever. Here's the general rule. We could have y equals a trig function, and we could multiply it by a, and we could have inside the parentheses bx plus c. Basically, a, b, c are all numbers. So this could be 3, 5, and 7, 2, 4, 6, or one of these could be 0. And then this trig function can be any of the six we know: sine, cosine, tangent, cotangent, cosecant, secant. And basically, the a, b's, and c's, depending on what number they are, that's what factors into the amplitude, the period, and the phase shift. So it depends on what trig function you're looking at. So we're going to make a chart, and we're going to break it down into three categories. Sine and cosine go together, cosecant and secant go together, and tangent, cotangent, kind of naturally. And we're going to start with amplitude first. So if you have to calculate the amplitude, for sine and cosine, it's the absolute value of a. Whatever number's out in front, you absolute value it. The other four different trig functions don't even have an amplitude to worry about, so there's none. So that's kind of nice to know. Then we're going to talk about period, and there's a formula to figure out the period. If it's sine and cosine over here on the left, then you're going to do 2 pi divided by b. Same for cosecant and secant, 2 pi divided by b. These match. It's a little different. Tangent and cotangent, it's pi divided by b. There's no 2. And you can pause the video and write these down if you need them. And then for phase shift, the nice thing is it's the same all the way across for all of these. You take negative c divided by b. So it comes right out of this rule up here. Negative c divided by b, negative c divided by b. And if you know these rules, I know they're kind of hard to commit all the memory, but if you know them, then you can really figure out any trig graph, basically. So we're going to try an example. We're just going to test this out and do it. And we'll call this example 1 or something like that. And let's do this. Let's graph y equals 3 cosine of 2x. So I'm going to go through the things that I need to know. I need to know amplitude. I need to know the period. And I need to know the phase shift. Or it would help me to know all these things. And then we're going to graph it. So over here on the other side, I'm going to set up an XY axis. With trig graphs, we have to be pretty careful because we know it goes in terms of pi's. So I'm going to be as careful as I can here and build a scale. And let's see. I'm going to do this. I'm going to go pi over 2, pi, 3 pi over 2, 2 pi. If I want to go backwards, it'd be the same thing. It'd just be negative pi over 2, negative pi. I'm just going to go that far. And we're going to go through and calculate all these pieces. So in this equation, this is my A, 2 is my B, and the plus C equals 0. There is no C in this problem. If you look, there's not a 2x plus anything. So to figure out my amplitude, I do the absolute value of A, which is going to be 3. And the absolute value of 3 is 3. So that's good to know. My period, I'm going to do 2 pi divided by B, and B is 2 in this case. So 2 pi divided by 2, which if I cancel the 2's, is pi. And to do my phase shift, it's negative C over B, so negative 0 divided by 2. Negative C over B, which is all just 0. So I know everything I need to know, I think, and now I'm going to jump into my graph. Let's talk about the regular cosine graph. Normal cosine starts at 1, and it just goes between negative 1 and positive 1. That's my phone. Anyways, okay, so, sorry. Starts at 1, and by the time we get to pi, it's at negative 1. By the time we get back to 2 pi, it's back at positive 1. And it looks kind of like this. And then it kind of keeps on going. That's the usual cosine of x graph. Amplitude breaks this out. Instead of going from 1 to 1, negative 1 to positive 1, it's now going to go to 3. So 3 to negative 3. So that's the first thing I know is I'm going to move my first point up to 3 instead of 1. The period is pi. This period right here is 2 pi. That's because it starts here and doesn't get back to that same spot until you get to 2 pi. So hopefully that makes sense. You start at 1, it never gets back to 1 until I get to 2 pi. Well, now I'm starting at 3, but instead of taking all the way until 2 pi, it only takes until pi. So by the time I get to pi, I'm back to 3. Hopefully that kind of makes sense. So by the time I get to pi, I have to be all the way back. And then there's no shift, 0 shift. So there's no left, there's no right, which is kind of nice. So I'm going to piece this graph together. If pi is going to be where I end, then pi over 2 must be the middle where I get down to negative 3. So this graph's going to go something like this. If you can see that. And it's just going to keep on going, so technically it keeps on going and kind of repeats itself over and over. And this one, which I should have made a different color. Let's do this. I'll put it in green. There we go. That's y equals 3 cosine of 2x. And there's my graph. So let's try another one that's a little bit different. And then I think we got it down. Example 2. Let's try graphing y equals sine of x minus pi as an example. So now we look for our ABCs. So A is going to equal 1 in this problem. B is going to equal 1, and C is going to be our pi. And we're going to find our 3 things: amplitude, period, and phase shift. And kind of go through those. And then over here, we're going to graph it. So set up my graph. And it's going to be the same setup. All these trig ones, you kind of set up the same. So I'm going to go pi over 2, pi, 3 pi over 2. And then I'm going to scoot over here so you can actually see it, 2 pi. And then I'll jump over here to the other side and say negative pi over 2, negative pi, etc. And so we're going to start with amplitude first and kind of cruise through this. Amplitude is the absolute value of A, and A is 1, so it's going to be the absolute value of 1, which is 1. Period is going to be the 2 pi divided by B, so 2 pi divided by B equals 1. So 2 pi divided by 1, so 2 pi. And phase shift is negative C over B, so it's going to be negative C over B. Well, C is actually a minus pi, so it's negative pi over B is 1, which means negative makes it positive, pi. And there's our setup. So here's what we do. We look at the graph and say, okay, usually sine bounces between 1 and negative 1. And it looks like our amplitude still's 1, so it's not going to move. So that's kind of good. Usually pi starts at the center at 0. And then by the time I get to 2 pi, it's usually back to 0 as a 2 pi period. And it goes up and down. So we're looking at kind of trying to piece this together here. It goes up at pi over 2, back down through pi, back up. And that's the regular sine of x graph. So now we mess with it. Amplitude being 1 means that it's still going to go in between negative 1 and 1. So that's good. Period being 2 pi means that it's still going to take a distance of 2 pi to get back to the start. So that's good. So nothing's changed yet. It's just the phase shift. We are supposed to shift this graph to the right by pi units. So all we're going to do is a shift. And so wherever the first point was here has to shift over pi units. So now the first point, I'll put it in green, instead of being here, is going to be right here. And the curve's going to do the exact same thing. It's going to go up and then back down and then up and back down. It's just it starts at this point before it starts doing it. Does that make sense? So it goes up, comes back down, goes back up, and continues its path. And I can work backwards here. Oops, I went down a little too far. And you kind of get the idea. So the only shift that really happened to this graph is we moved it to the right, pi units. And that's it. And so this green one is y equals sine of x minus pi. And we got our graph. Oops, there you go. So basic shift laws, really all you got to remember is you have to remember these rules that I had up earlier. If you can stick to remembering these, then you're going to have trig graphs down for the most part. So hopefully that helped.